All right, so welcome. Let's see, what page are we on here? This is page number 14 in the practice section of our notes. So let me just jot that down over here. So this is page number 14. So in this page, we're going to be doing Lewis dot diagrams. Remember, if you have to draw a Lewis dot diagram, you probably better draw some dots. And so this is a way to indicate the number of valence electrons, which, right, we already know these are the last number, oh, not lab, last number in the electron configuration on the periodic table, which is underneath each symbol. So just back to our reference tables, right? The last number in the electron configuration is, so if I just make this a little bit larger so that I can circle. All right, so whatever the last number is, right? So magnesium and calcium and strontium and barium, right? Those all have 2 valence electrons, right? The last number in the electron configuration. All right, so now that's how many dots. The number of valence electrons is going to be the number of dots that we're going to draw when we're doing the Lewis dot diagram, an element. So let's get started. So I'm going to take my symbol, Ca for calcium. So you need table S if you're not familiar with the symbols yet, which by now you probably are. And then you also need your periodic table so you know the number of valence electrons. So calcium has 2 valence electrons. And so I like to do the first 2 or a couple on the bus. So because we have to fill that first energy level first, and that holds 2 electrons. If you're familiar with the s, p, d, and f orbitals, right, with the advanced electron configuration, right, the 2 dots together represents filling up the s orbital, and then we have our p orbitals, which are the 3 orbitals along the other sides. All right, so let's go over here. So for the sake, so since I don't have to scroll down and up and make us dizzy with the computer scrolling, let's do carbon. So carbon is a very unique element, which is why we have a whole branch of chemistry called organic chemistry named after carbon, because it has 4 valence electrons and it can do all kinds of things, and it can make a lot more bonds because it has to make 4 bonds. So carbon has 4 valence electrons, and there's 2 ways we can draw this, right? So there are 2 together, 2, and then now 1 at a time, 3 and 4. Okay, so that's one way. Or when we get to our organic unit, actually carbon really has these 4 valence electrons spread out, and we call this to the 4 corners of a tetrahedron, which we'll look at later. So carbon can be written either way. This is the preferred organic chemistry way to draw carbon. All right, so let's go down here to potassium. All right, so potassium symbol is K, because P is for phosphorus. And potassium has 1 valence electron, so it just gets 1 dot. Easy. And now we'll go to helium. And helium has 2 valence electrons, so it gets 2 dots. And of course, you can put the dots really on either side, but because I'm a science person and I like things to go nice, neat, and orderly, I like to go clockwise and starting at the top, but that's just personal preference for me. Argon is a noble gas with 8 valence electrons. So I'll show you how they fill, right? Filling order from the lowest energy to the highest energy. So we fill up our first energy level with that, right? So 2. And now all the other ones want to get as far away from each other as possible because electrons are negative and like charges repel. So they only share a side if they absolutely have to. So 1, 2, right? Remember, I have to get up 8. 3, 4, 5, and now 6, 7, 8. 8 valence electrons. Now oxygen has 6 valence electrons. So I'm going to draw O for oxygen, and then 1, 2 together at the same time, right? The first couple on the bus are together, then everybody else wants to spread out because nobody wants to be near the couple. 1, 2, and then 3, 4, 5, and now 6. 6. If I push too hard on this pen, I try to make circles, and then I get all kinds of weird stuff. So notice how I have an open spot here and an open spot there, right? Because oxygen makes 2 bonds. So let me just make that look a little bit prettier. Maybe I'll just use X's. So 2, 3, 4, and 5. Oh, sorry, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, sorry, and 6. Okay, sometimes you might see them represented as X's in test questions because you do. So it can be really any symbol, because remember these dots, you know, electrons are not literal dots around symbols, right? This is just a model of what the electrons are doing. Aluminum has 3 valence electrons, so I have my symbol for aluminum, and I have 1, 2, 3 valence electrons. And now I have my phosphorus, right? And so phosphorus has 5 valence electrons. So 1, 2, and now 3, 4, 5. So notice how phosphorus has 3 open spots, and phosphorus needs to make 3 bonds. It is 3 places away from a noble gas on our periodic table for covalent bonding. So now I have bromine. So I have bromine. Bromine has 7 valence electrons. So 1, 2, 3, 4, 5, and then 6 and 7, right? 1 open spot for bromine, right? 1 electron away from a noble gas. Hydrogen just has 1 valence electron. And there we go. Of course, you could also write it like this, right? So it's all the same, right? It's just different modeling in the way that we do that. All right, so I am going to stop this here, and in the next set, I will do ionic bonding. And how do we take these Lewis dot structures and form ionic bonds?